Good day. The theme of our lesson, the space group or Fedorov group. You can see the definition. What is it, the space group? A space symmetry group is the set of possible symmetry elements of crystal structure. A special symmetry group characterizes the crystal structure symmetry in the same way as a point symmetry group characterizes the symmetry of the crystal external shape and its physical properties. Each point group there correspond several special groups. From a special symmetry groups of the crystal, it is easy to obtain its point group. To do this, one must mentally destroy all the translations, that is, transform the sliding reflection planes into the mirror ones, and the screw axis into simple rotational ones. To derive from the point group all the special groups corresponding to it is a more complicated task. So, for example, if the axis group includes axis 3 and 2, then in the special group the axis can be in the form of 3, 1, 3, 2, 2, and 2, 1, and the combinations are possible. So this is the result of 230 special discontinuous symmetry groups of the crystal structure, or another name is Fedorov symmetry groups. This name is spread because the Russian crystallograph Fedorov, the professor of Moscow University named Lomonosov, opened this and proved the presence of these special symmetry groups, though this name is not popular abroad, of course. The Fedorov groups were derived in 1890 till 1894 years simultaneously and independently by Fedorov and Schoenflies. So the Fedorov group is a popular name in the Russian or the former Soviet republics, but abroad these groups are called the Schoenflies groups, of course. We will use the name international, the special symmetry groups. These groups are opened by Fedorov and Schoenflies, I repeat, simultaneously and independently. 20 years before the existence of special groups was proved experimentally. Of course, it was impossible only by the X-ray. A special group is characterized not only by a set of symmetry elements, but also by a number of symmetrical equivalent positions. The slide, you see the example, some minerals or object from the nature. These objects has the crystalline structure as a mineral, and here you can see how this mineral belongs to this or another spatial group. For example, the mineral zircon has a crystalline lattice I41 AMD symmetry. It means that zircon has body-centered lattice. Of course, the screw axis of fourth order, and of course the diamond gliding plane symmetry. And another picture, you can see the honeycombs have C6H symmetry, hexagonal symmetry. Yes. the classification of to the